This is Wednesday, August 26th, and this is the solutions to the second review for your Chapter 2 test, MXL 13, and its title is Section 2. Chapter 2, Review 2. So let's get started. All right, our first question is to determine whether or not these two functions are inverses. So on the summary notes that I gave you, to be inverses, when you do the composition of these two, you need to end up with the identity function. So when we do the first composition, we want to see if we end up with x, which is the identity function, y equals x, and then if we do the composition in the other order, with g as the outer and f as the inner, then we want to see if we get x for that. And if we get x for both of these, then we can say that these two are inverses of each other. So here are the two compositions. This is g going into f and the associated algebra, and we end up with 2x minus 15. So this does not equal the identity function x. So we know right now these are not going to be inverses of each other. Okay, the second part was finding the composition the other way around. So g of f, and I end up with x minus 1 over 3, which again does not equal the identity function. So when they don't equal the identity function, then they're not going to be inverses. All right, the second question is asking you to do the same thing. So I do my two compositions. So here's the composition with g as the inner function, and the composition with f as the inner function in the associated algebra. When these simplify, they both become x. So they both equal the identity function when you do the composition. Therefore, they are both inverses of each other. On your function summary, the steps are listed on how to take a function and find its inverse. First step was replace f of x with y, then switch x and y, and then solve the equation for y. So here's the work that I went through, and we've done several of these in the notes that follow the same sort of pattern, and I end up with the inverse of the function being 6x minus 1 over x minus 2. The graph of function f is shown. Use the graph to draw the graph of its inverse. So what you're going to do is just take these points and switch their x and y coordinates. Whoops. All right. So the coordinates that I have here are, this would be 2, 3. So I'm going to plot that as 3, 2. All right, this second point here is negative 3, positive 1. So that's going to become 1, negative 3. And then my last point is negative 4, negative 4. So that's going to stay negative 4, because when I flip them, it's the exact same thing. right? And then I'm going to connect my dots here. So here and there. Okay, that is a reflection of that graph over the line y equals x. Okay, so the line y equals x is a 45-degree line that goes through the origin. And you're just flipping that graph over that line. All right, the next question is doing the same thing. So my first point here is 0, -2. So it's going to become -2, 0. My second point is 2, -3. So that becomes -3, +2. And if you needed to, you could graph some more points. Okay, like this one down here. This is what? -6. 1, 2, 3, 4, -6. And that's going to become -6, 4. And it's a reflection of this point over a 45-degree line. So our line would look something like this. Which is choice A. All right, number 6. Given f of x equals x² - 8, the domain has been restricted. So you're only going to have the positive half of this parabola. So you can graph, if you're not sure what that looks like, you can open up Desmos and you just type in that function. So I typed in the function, x² - 8, and then I use fancy bracket, x greater than or equal to 0. So it just draws the right half of the function so that it has an inverse. All right, and we know that, let's see, the y-intercept on that graph was 8. So we know just before we even do anything here that our choice is going to have to be D, because this is our original function right here in this black line, because that's the only one that has the correct y-intercept. All right, so we want to find f of the inverse. So to do that, we switch x and y, or we get rid of f of x. Then we switch x and y. Okay, add 8 to both sides. And take the square root. And then replace the y with our inverse notation. So there's our inverse. And then we graph that one. And then I take my points and I just switch them. I pick a couple of points on here, like we knew we had the point -8, 0, -8. So on my inverse, that's going to become -8, 0. And then you can pick another point, one that it goes through. Okay, and flip those two, and that gives you your graph. And again, your graph will always be symmetric with respect to the line y equals x. You're just folding it. It's like you're folding it right over that line. Okay, it says then state the domain and the range of f and f of x. All right, so on the summary that I gave you, the domain of the original is equal to the range of the inverse. And then the range of the original is equal to the domain of the inverse. So if I was looking at this graph right here, the one that we graphed on Desmos, okay, I can see that the domain of this graph is 0 to infinity to the right, and the range is from -8 to +infinity. Now all I got to do is just switch those two, and that's going to give me my domain and range of the inverse. Okay, so in this problem here, in this graph, the black line is the original, the red line is the inverse, the red curve, the black curve is the original. So when I look at that original there, the domain of the original was 0 to infinity. So then that becomes the range of the inverse. Now when I go back to this, this was the domain, and this is the original. Okay, the range of the original, well, the lowest point is -8, and then the highest point is infinity. So that's going to equal the domain of the inverse. They're just switched. And that's where we get -8 to infinity. So that's an important concept with inverse functions, is that they're switched that way. All right. Number 7 is given the function x cubed minus 4, find the inverse. So we're going to go through the same process we did in the previous problem. Okay, so here is my graph. All right, this is the original. Now it says graph f and its inverse on the same coordinate plane. So we'll bring that over, and this was supposed to be a plus. So there's our graph, and you can see that that is symmetric with respect to the line y equals x. Use interval notation to give the domain and the range of f and its inverse. All right, so when we do that, bring this graph back over. Okay, so the domain of the function, that's the red graph, becomes the range of the inverse. The range of the function becomes the domain of the inverse. Okay, find the inverse of this linear function. So this is pretty straightforward. Okay, switch x and y, solve for y. All right, does the graph have an inverse function? And the answer here is no, because it fails the horizontal line test. Okay, the original function here is a many-to-one function. And many-to-one types of functions do not have inverses. They are not invertible. Okay, there are two x-coordinates that have the same y-coordinate. So like, I'm just estimating here, but -1 has a y-coordinate of -6, and 4 has a y-coordinate of -6. That makes it a many-to-one function, does not have an inverse. Okay, our next one, same question. Okay, this is yes, because it passes the horizontal line test. It only touches it once.